this experiment is verification of Thevenin's theorem. As you can see here, we have a circuit which, for which we will be giving the AC supply, which has two fixed resistances R1 and R2 and a load resistance rheostat of RL, which is of variable, and it has an ammeter and a voltmeter. You would have studied this Thevenin's theorem in your theory class. In this laboratory experiments, you will be experimentally verifying that Thevenin's theorem. At first, we will be connecting only R1 and R2 across the AC source, and we will be measuring across this A and B terminals. We will be measuring open circuit voltage, which is VOC. We will be connecting a voltmeter across this terminals, and we will be measuring the open circuit voltage VOC. After measuring the open circuit voltage, we will be connecting an ammeter across this terminal, and we will be measuring the short circuit current ISC. Okay. So from this, after measuring the VOC and ISC, E Thevenin will be open circuit voltage VOC, and R Thevenin will be VOC divided by ISC. Once we have found out this R Thevenin, then we will be connecting this ammeter and variable resistance, which is rheostat, and a voltmeter in parallel with the rheostat. So once you have connected it, then you will be varying this rheostat for the various values. You will be noting that value of current, voltage and current for the various values of the rheostat. Then we will be verifying that the current, actually measured current, and the current through the Thevenin's theorem, which is current through the circuit will be E Thevenin divided by R Thevenin plus RL. E Thevenin for this circuit will be the applied voltage across here, which will be we will be applying same as that of the VOC. Now we will be measuring the short circuit current in order to find out the Thevenin's equivalent resistance. As you can see here, this is the auto transformer from which we will be slowly increasing the voltage. This is the multimeter we have kept in AC voltage mode in order to check the exact voltage, in which we will also be doing the open circuit test. This is an ammeter just to verify that current won't be exceeding the rated value of these resistances, and this is an ammeter in order to measure the short circuit current. Now I will be keeping this auto transformer at a constant voltage. I am slowly increasing the voltage. I have kept the voltage at 60 volts. As you can see, current has not exceeded the rated value, and we will be calculating the rated current from this ammeter, short circuit current from this ammeter, which is actually around 1.1 ampere. And I will be reducing the voltage of the auto transformer. Now we will be conducting an experiment to measure the open circuit voltage. I have removed the ammeter here, and I have connected an voltmeter of range 0 to 75 volts. Auto transformer is at 0 position, and I have connected a multimeter here in order to measure the input voltage, and this ammeter is just to verify that the current won't be increasing the range of these rheostats. Now I will be slowly increasing the voltage from the auto transformer. As you can see, the increasing voltage in the multimeter. I have kept the voltage at 60 volts, and the current in the ammeter is also not increasing the range. And as you can see here, the open circuit voltage of this circuit is around 28 volts. Now I will be reducing the auto transformer to 0 before switching off. Now I have connected a load rheostat in parallel with the circuit. As you can see here, the value of the load rheostat is kept at the maximum position. I will be slowly reducing the value in order to take down the readings. I have connected an ammeter in series with the rheostat and a voltmeter in parallel with the load rheostat. I will be keeping the voltage at the previous value, which is at 60 volts. Now I am slowly increasing the auto transformer in order to keep the voltage at 60 volts. I have kept the input voltage at 60 volts. This ammeter is just to check that the current is not exceeding the rated value. As you can see here, now we will be taking the readings by varying this rheostat. As it is connected. As you can see, when I am varying the rheostat, voltage is reducing and the current is also varying. Now you have to take the readings by varying this rheostat at the different values. Now I am reducing the auto transformer before switching off. After performing the experiment, we have tabulated this table, and the input voltage for the circuit, as you know, as kept at 60 volts, and each Thevenin was found out to be 28 volts, and our Thevenin was found out to be 25.45 volts. So these are the measured values for the different values of resistances. As you can see here, we have found out the resistance by dividing the voltage and the current. So these are the different values of resistances, and from this formula, this is the measured current, and this is the current found out by using Thevenin's theorem. As you can see here, in all these cases, the current measured current is 0.2 ampere. The Thevenin current found out from Thevenin's theorem is 0.199 ampere. Similarly, all the current tabulates with the measured value of the current. From this, we have verified the Thevenin's equivalent theorem by performing the experiment.